In this video, I'll go over exam questions, two of them, that didn't have the answer properly formatted in Blackboard. If you are wondering how to do another problem and you're completely confused, just let me know and I can help you through that. So our first question here is our titration problem. Now everybody got different variables for our numbers here, so I just made some up. But no matter what numbers you had for the actual problem, solving it is the same way. So we have a titration of 150 milliliter sample of 0.250 molar HBr. And we're going to titrate that with 0.125 molar sodium hydroxide. First, determine the initial pH. Well, HBr is a strong acid, and you know it's a strong acid because there's no Ka value. So to get the pH of a strong acid is, well, first, what is a strong acid? That means it's going to dissociate 100%. So if we have 0.25 molar HBr, we have 0.250 molar H. And so we can do pH, because we know the H concentration, which is minus log 0.250, so our pH initially is 0.6. B, how much base do we need to add to reach the equivalence point? The equivalence point is when the amount of HBr and NaOH are the same. The molarities, the volumes, it's the amount of H that's been added is equal to the amount of OH that has been added. That's how I should say it. And if we write down the equation for HBr and NaOH, we find it's a 1-to-1 ratio, which means 1 mole of HBr will react with 1 mole of NaOH. And when you have a 1-to-1 ratio like this in acid and base, you can simply do M1V1 equals M2V2. So here we have that. We have 150 milliliters of our acid equals molarity of our base. We're trying to find out the volume of base. So actually the way I have it is V1 times M1 equals M2 times V2. So I'm mixing it up a little bit, but it should work. We solve for X, and X is 300 milliliters. So I need to add 300 milliliters of base to neutralize this acid. C, what's the pH of the equivalence point? Well, if you have a strong acid and a strong base, the pH at the equivalency point would be 7. D, what is the pH of adding 12 mils of base beyond the equivalency point? Alright, so let's see how much volume our titration is up to this point. We started with 150 milliliters of acid. We added 300 milliliters of base to get to the equivalency point. And then we added 12 more milliliters of base after that. So our total volume is 462. Well, how many moles of OH have we added? Well, our molarity of NaOH is 0.125. And we added up 12 milliliters, or 0.012 liters, which is 0.0015 moles. So the concentration of OH is 0.0015 moles of OH divided by the volume in liters, which is 0.003247. If I know the molarity of OH, I can get POH, because it's just minus log molarity of OH, which is 2.49. And if I know POH, I know pH, because POH plus pH equals 14. So 14 minus POH equals pH, or 14 minus 2.49 equals 11.5. So our pH of this solution is 11.5. Our second question is our delta G of reaction given these following conditions. So we have a reaction where 3 molecules of oxygen make 2 molecules of ozone. Delta G naught is 250 kilojoules. So what is this reaction if O2 is 0.125 atmospheres and O3, the pressure of O3 is 1.53. So we set up our equation. Delta G equals delta G naught plus RT multiplied by the natural log of products over reactants. So it would be O3 raised to the power of 2, because we have a stoichiometry of 2, divided by O2 raised to the power of 3, because we have 3 moles here. So then I just plug in all my variables. So R is 8.314 times 10 to the minus 3 And it's times 10 to the minus 3 because we're in kilojoules, so my R needs to be in kilojoules. My temperature is 298. O3 is 1.53. O2 is 1.52. Solve for that and you find delta G is 251.55 kilojoules. And that's it for this video. If you want me to go over other questions, please let me know and we can talk about that. Otherwise, good luck on the final.